This is the notes on solving. Kind of a quick way to say it is solving exponential, right? Because we've been working with exponents. Solving exponential equations. Now we got equations. When you hear the word equations, that means you're going to have an equal sign, right? Yeah. You're going to have an equal sign, and then that means solve. Well, that means you're going to have to get an answer. Sometimes it's answers, but exponential equations. Right, we're gonna solve stuff now. Another way that they might say this or whatever will be something like solving equations with what have we been calling exponential equations? Rational what? Yeah, rational exponents. Okay. Anyways, here we go. Solve. I'm going to put a problem here and see if anybody can do it. Ready? Just to put an easy one out there. 3 to the power of x, right? Because you're going to be looking at exponents, equals 3 to the power of 5. Anybody get the answer? 5. Correct. Done. Ismail, why is the answer 5? What does equality mean? What does it mean for things to be equal? Well, that means we get equivalent values, right, in math? If the base, right, if the base is 3 here, and that's equal to this base that's here, I don't care what these bases are, right? They're already equal to each other. If this is equal to this, now you can set the exponents equal to each other. Set the exponent part, right? These exponents equal to each other. And then solve, but there's no solving for this one. Let me write this down. But you first have to meet this condition. First what? The bases must be what? Bases must match, or bases must what? The bases must be what? The same. If this was not a 3, if this was some other number, then I'd have to find a way to make it a 3 or it won't work. Does everybody see why the answer is x equals 5? Because if I put this equal to this, what happens if I put x equal to 5? Well, there's nothing to solve, right? If I put x equal to 5, well, isn't it already solved for? It's already done. Okay. Too easy. Is that understood? Okay, let me do another one. Number 2. That one was too easy. This one's going to be easy, but not so easy. Okay, here we go. 4 to the power of 2x equals 4 to the power of 6. Do we have the bases the same? Yeah. So when the bases are the same, I don't even care what this number is. This could be 6 and 6. This could be 8 and 8. Once these are the same, I don't have to look at that anymore. I just got to solve up here, right? Don't I got to solve right there? And since this is equal to this, you put 2x equal to 6. What's the answer for that? X is equal to 3. Do you guys see how easy that is? Now we can make problems like this look super complicated, can we? I mean, I could put something like this and it's going to look super complicated. But honestly, how about if I put 7 to the power of 3x plus 5 equal to 7 to the power of x plus 21. I mean, I could do something like this. But honestly, what? If the base is already the same, am I really having to work with the 7s or whatever this base is? No. Once these are the same, you just put what equal to each other? The this stuff up here, the expressions and the exponents. Does everybody agree we have to solve this and put those equal to each other? Yeah. What would that be? 3x plus 5 equals to what? X plus 21. You should be able to solve that. Go ahead, solve that. How do we solve that? Well, that would be don't you have to move all the variables to one side and all the numbers to the other side? So that would be 3. I'm going to move this positive 5 over there and this x over, right? Redo that. So it would be 3x minus x equals 21 minus 5. Did you guys get that? And then you'd eventually, you could have done it a couple of different ways. But eventually you'll get to 2x equals what? 16. And then we're going to solve for, sometimes it's x or a or m or whatever variable. But you guys get it? X equals 8. Are we good? Are we good with this? Okay. Too easy, right? All right, here, let's step it up now. What if the bases don't match? Okay, let's look at number 4. What if I get 6 to the power of x equals 36? Those don't match. Well, guess what? We need the bases to match. The bases don't match. We need to make these match. The bases must what? Bases must match, or they must be the same. Well, right now they don't. 6 is not the same as 36. But we've been working with bases and exponents, right? Is there a way that I can change this 36 to have a base 6? Can I rewrite 36 with a base 6? Yeah. What is 36? 6 to the power of what? 2. Come on, you guys know that's easy, the squares, the square ones. And see, now the answer is what? 6 squared? The answer is what? Once I get the bases to match, then you just look up here and you just solve whatever's up here. X equals 2, well, there's nothing to match, right? There's nothing to solve. It's already x equals 2. You guys see that? Okay, how about this one? Number 5. Let me step it up. Step it up. Okay. How about 3 to the power of 6m equals 9. Well, we got to get these bases to match. Can 9 be written as a base? Of course, 9 can be written as a base of 3. So this is really 3 to the power of 6m is equal to 3 to the power of 2. Isn't 9 3 squared? Yeah, now I got the bases to match. Once the bases match, I don't need to look at the bases anymore. Do you guys agree with that? Once the bases match, I got to solve this. How do you solve 6m equals 2? What's the answer? Does somebody say 3? I see a 2, I see a 6. The answer is 3? No. So how do you solve this, you guys? Well, I'm trying to get the m and isolate the m. Don't you divide by 6? And you divide by 6, right back to our algebra 1 solving equation stuff. What are you going to get? M is equal to 2 over 6, but I'm not going to leave 2 over 6 because you always check to reduce when you have a fraction. Final answer is, 1/3, right? Reduce. Always check to reduce when there's fraction. You can get a fraction, okay? Fractions are Fractions are numbers too. Okay, number 6. Number 6, ready? 2 to the power of 3n. I'll put 3h. 2 to the power of 3h is equal to 64. Oh, yeah. (64) can be written with a base of 2 and an exponent. Anybody know what it is? Let's see. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. Anybody know what 64 is? 8. 2 to the power of 8? Incorrect. 2 to the power of 5? Incorrect. 2 to the power... Oh, what? 2 to the power of 5 is... You guys don't see a pattern here? Times 2, times 2, times 2, times 2 would be what? And then 2 to the power of 6 is? 2 to the power... I mean, you guys have calculators too. If not, go to your calculator on your laptop there. Everybody agree? Can see why 2 to the power of 6 is 64? All right, let's see. If you truly understood this, what's 2 to the power of 7? Correct. Okay, but we're not looking for 128. Everybody agree this is the one we want? So 2 to the power of 3h is equal to 2 to the power of 64 is what? 2 to the power of what? 6. All right, how do you finish this? Once I get the bases to match, I don't need to look at the bases anymore. I just look up here. I set whatever expressions are left on the exponents, I solve this. I put those equal to each other and I solve it. What am I going to put together to solve? 3h equals 6. Is that right? What's the answer? 3 times what number gives you 6? 2. Come on now. All right. Okay, number 7, because we're stepping it up, right? We're taking it to a more complicated level. Oh, wait a minute. That's not right. 7 to the power of 2k plus 1 is equal to 343. Wow, what do you think your base is going to be, you guys? 7, right? 7, right? Because this one's 7. So check if 343 can be written with a base of 7. Well, let's see. What's 7 to the power of 1? Well, 7. What's 7 to the power of 2? 49. So I know it's not 2 because 7 squared is 49. What's 7 to the power of 3? Anybody can do 7 to the power of 3? What is it? 343, right? Isn't that the one we want? Because that's a number right there. So 7 to the power of 2k plus 1 is equal to 7 to the power of what? 3. All right, how do you finish and continue this? Once the bases are equal, I don't need to do anything with the bases. I put these expressions and solve this, right? What am I going to write? 2k plus 1 equals 3. Okay, solve that. The answer is 2? Dean did it in his head and he got 2.
Wait, hold on. Wait, no, yeah, it's 1, yeah. I got it right the first time, but then I second guessed myself because I thought we would have to move it over.
Don't you do subtract 1? So that'd be 2k equals what? Not 4. 2k equals what? 2. Here the answer is k is equal to 1.
The first time I just did it. Like, yeah.
Okay. You're not going to get this one, but it is possible. It is doable. You can do it. You just don't know something right now. Number 8. Ready? Number 8. 5 to the power of x is equal to 1. Anybody know the answer? No, I mean, sorry, I shouldn't be asking for answers. Anybody know how to do this and get the bases to match? Isn't that the objective here, to get these bases to match? If these bases don't match, we can't do it, at least not this way. Anybody know how to do this one? You don't. I'll tell you why you don't know. Because 5 to the power of x is equal to 5 to the power of 0. Any number to the power of 0 is 1. Any number to the power of 0. Go ahead and try it. Any number to a power of 0. 5 to the power of 0, 1. You see it there? When you see a 0 power, 2 to the power of 0, what's the answer? 1. 3 to the power of 0, what's the answer? 1. 4 to the power of 0, what's the answer? 1. Or going backwards, when you have a 1, you could write it with any base and put what exponent? A 0. Yeah?
With any number?
Well, what number are you thinking?
Like 100,000.
Yeah, you can. That'll be 1. Okay, what's the answer for this problem, you guys? Once I got 5 equal to 5, you put x. You just look right here. X equals 0. Answer is x equals 0. Right? Because once the 5 is equal to 5, you just set that equal to. Don't you? Doesn't it say x equals 0 right there? It's looking at you. Okay, we're good? All right, let me see. I think you have a couple of these. Ugh. Okay, here we go. Number 9. How about 2 to the power of x equals 1 over 8? Oh, yeah. Now, when you see the 1 like this over 8 like this, don't sweat it. Don't worry about this 1. This one is not like this one over here. I want you to just focus on the whole number. See this whole number? What is the base here you're working with? Anybody? I mean, the hint's right there. 2, right? The base is 2 because I can see this one has a 2. Can you write this 8 with a 2? Yeah, we know that, right? That would be 2 to the x equals 1 over what? 2 to the power of 3, right? 8 is 2 to the power of 3? Yeah. And I don't want fraction stuff like this. But remember with exponents we can move things up and down? What happens when you move things up and down? You guys remember that? It changes sign. You guys agree it changes sign? So when I move this up, what's going to happen, everybody? You're going to be looking at this. 2 to the power of x is equal to 2 to the power of negative 3. And then you can see what the answer is right there, right? Everybody can see the answer right there. It's looking at you. There's nothing to solve. X is equal to what? X is equal to negative 3. We're good with that one? Okay, 10. 6 to the power of 3m is equal to 1 over 216. Well, I know what my base is going to be. Everybody see this one's a 6 right here? So I got to find a way to write 216 with a base of 6. Anybody know what that is going to be? 6 to the power of 1 is 6. 6 to the power of 2 is 36. What's 6 to the power of 3? Well, guess what? It happens to be 216. You guys agree with that? Yeah. So really I'm going to write 6 to the power of 3m is equal to 1 over 6 to the power of what? 3? Yeah. Hey, what happened to this thing? Oh, there it is. And then what are you going to do? Move it up. What's that going to be? 6 to the power of 3m equals 6 to the power of negative 3. We're catching how this has got to go? And then what are you going to solve this? You're going to solve this. 3m is equal to negative 3. Come on. We got it? M is equal to negative 1. Okay, last one. 5 to the power of 3x minus 2 equals 1 over 625. Bless you. Anybody know what 5 to which power gives you this 625? Let's see. 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 to the power of 3 is 125. Anybody know what 5 to the power of 4 is? 625. How do I know that I have to use a 5? Well, hello, there's a 5 right here. They have to match. 5 to the power of 3x minus 2 equals 1 over 5 to the power of 4. Did everybody write that? Yeah, don't skip that step. Then what happens? Then when you move this 5 to the power of a positive 4 up, what's gonna happen there? 5 to the power of 3x minus 2 equals 5 to the power of negative 4, right? Because you change the sign of the exponent, right? When you move them up or down. Yeah, we've learned that before. And, oh, well then we got them to match. The bases match now. The bases match now. Right? Once the bases match, which is our objective here, right? The 5 is equal to the 5. I don't have to work with the 5s. I just got to solve which part? These expressions, and solve this. Okay. So that's going to say what? 3x minus 2 equals what? Negative 4. Anybody got that one? What is it going to be? That's going to be 3x equals what? Negative 6? Negative 2? Yeah, because you add 2 and you add 2, or you move it over here. Correct, it'll be negative 2. Your answer is x equals negative 2 over 3. We're good? Okay, you're good. You got it? One more, or you got it? We got it. Okay, that's it.